Hi, my name is Elio D'Amaggio. We're going to talk today about connecting devices to the Azure IoT suite. The agenda will mostly focus about connectivity capabilities of the Azure IoT suite. We're going to start by talking specifically about the connectivity component inside Azure IoT suite. We're going to introduce it. It is called Azure IoT Hub. Then we will then focus on device identity and provisioning, then messaging, cloud to device and device to cloud messaging. We're going to talk about gateways. They're very important for connecting devices to the cloud. And then we're going to talk about monitoring of connectivity. Azure IoT Suite contains many components and has like many capabilities. Usually you want to connect devices to your application backend, and that is kind of the first step that gets you started in your IoT solution. There are many kinds of devices, of course. Many doesn't even begin to describe that, but let's classify them between devices that can connect to the internet and devices that cannot, or personal area network devices. They're usually handled in slightly different ways. And then, of course, there are a lot of variety with respect to platforms, hardware, operating systems, and various stacks that you can use on the device. For IP-capable devices, you can connect them directly to your cloud. We will see how inside of Azure IoT Suite, we suggest to use the IoT Hub component to do that. That has many advantages that we're going to talk about today. You can also go through what we call a cloud protocol gateway, which can be custom or can be derived from an extensible gateway that we provide. And that is usually used for protocol translation, custom authentication schemes, brownfield scenarios, those kind of situations. For devices that are not capable or for whatever reason they cannot connect to the internet, usually a pattern that we see is the use of a so-called field gateway, so an aggregator which performs many tasks. Some of those are usually translating between short-range protocols, things like Zigbee or Bluetooth or 6LoWPAN and the like, and a more standard IP protocol with which you can then go to your cloud. Now, that of course is not as easy as I make it to be, but for the purpose of this talk, we're going to consider only for the connectivity aspects of what field gateways and cloud gateways do. On your backend, there's, of course, your event processing pipeline. Think about Stream Analytics, Storm, Spark, whatever custom event processing engine you might have. There is, of course, your device runtime logic, everything that handles your real-time functionality for your application. And, of course, there is device provisioning and management. In this talk, we will mostly focus on how to connect devices to the Azure IoT Suite and how basically you make use of that connectivity. Once you have data flowing in and the ability to contact devices, you're basically you're actually building your own business logic, and there are actually many other great talks at this year's Ignite regarding IoT scenarios in event processing and how to code scalable compute business logic for devices. So there are, of course, many aspects of connectivity. The first one is of course, which functionalities are provided when you want to enable connectivity between devices and backend. There are, of course, telemetry coming from the devices, or of course commands and notifications coming from the cloud, bulk uploads and downloads, so on and so forth. So the functional aspect of this communication. There is, of course, security, and that is a whole big topic. There's device security, there's cloud security, channel security. There is a talk tomorrow by Clemens Vasters on IoT security fundamentals. In this talk, we will mostly focus on device access, and how basically you get to authorize specific devices, but that is just a very little aspect of an IoT solution security discussion. There is, of course, monitoring. This is sometimes is not really considered. In most IoT solutions, devices are not reachable, which means that if something is wrong with device connectivity, it's really hard to debug or to fix the issue. In that case, in those cases, you effectively want to have a very verbose monitoring of the connectivity status between your backend and your devices. It's not a symmetric system. It's not, we cannot just send an error to the device and the device logs it somewhere and then that's basically where it ends. So we're basically tackling monitoring explicitly in the Azure IoT suite. And then, of course, there's reach and customization. We want to be able to allow you to reach all the devices on all the platforms. And here, platforms has, I was having like a hard time using the word platform because it's not really clear from the context what I'm talking about. There's hardware platforms, there's operating systems, there are software stacks. Basically, all of those aspects are going to be considered in the reach of the Azure IoT suite. There are, of course, network and application protocols. You might have, your solution might be deployed in environments where certain decisions have been already made, and you effectively have to support specific protocols. And again, here protocols are at the whole, at any level of the stack. You might be forced to use 6LoWPAN, and then you can decide what kind of application level protocol you might you might decide HTTP over AMQP over MQTT on top of other transports. And of course, authentication schemes. There could be previous investments in authentication components. There could be specific requirements that you have on your authentications that you might want to bake in the solution. So the Azure IoT suite have to let you implement those methods when you're, and still take advantage of the IoT suite capabilities. So the Azure IoT suite component that handles connectivity is called IoT Hub. It is, of course, designed for IoT. This is a new service. First, let me ask a question. How many people are familiar with Service Bus? Okay, good. Nearly everybody. Okay, so usually messaging systems are symmetric systems. They basically connect nodes inside a data center or in two data centers. So senders and receivers are mostly treated equally. In an IoT solution, a device is very different than a node in your backend. It has to be treated differently from a communication and connectivity perspective. And this is what we're doing with IoT Hub. IoT Hub implements the pattern called service-assisted communication. It has been popularized with this name by Clemens Vasters. We have like there's a great blog post about it on MSDN. Essentially, it basically describes the communication patterns where devices should not be treated as servers, mostly because we usually have a hard time handling like 100 servers in a data center. You do not really want to handle 1 million little servers scattered around the world. And also there are very, very important security considerations that happens when you have every device act like a server. larger attack surface. It's harder to update and to manage. The idea behind service-assisted communication is to use a service, in this case is going to be IoT Hub, to effectively mediate and broker communications between your devices. Now, of course, there are scenarios where you need to have peer-to-peer connectivity and you need to have a direct local connectivity. We are not saying that those scenarios are not valid. They of course are, but usually you can have a mix of both and still trying to take advantage of service-assisted communications for all the scenarios where it makes sense. It is, of course, it does provide cloud-scale messaging, device to cloud and cloud to device, and it does provide reliable messaging as well, which means that you do not have to handle transport and communication problems in your application. You do not have to handle retry logic and all of those things at the lowest level. When you will handle retry logic will be at a higher level, will be when you really want to, when the retry has a business logic meaning and consequences. We were talking about monitoring, and one of the things that we expose in that respect is cloud-facing feedback. You're going to get delivery receipts and expired messages and all the errors that happen on the communication channel to your delivered to your cloud backend. That allows you to effectively react accordingly and not having to implement a whole bunch of timers and timeouts and trying to implement a reliable channel on top of an unreliable one. IoT Hub also does provide per-device authentication. So IoT Hub has a notion of device, and you're able to provide per-device credentials and security materials, and also to have to authorize and provide a fine-grained access control on a device level, not just on a Hello? Okay, great. Okay. There is then connection multiplexing. IoT Hub will allow you to send multiple directions of communications on the same connections, and also multiple devices communications on the same connections, thus saving resources for small devices that are not able or do not have the resources to handle multiple connections, and also for gateways that are effectively handling already many connections and do not want to maintain more than required. When you are in the scale of thousands, hundreds of thousands, and millions, having to maintain 2 connections instead of 1 per device is a big deal. And of course, it is multi-protocol and multi-platform. It natively supports AMQP and HTTP, and is designed for extensibilities to custom and other protocols. And of course, it is multi-platform in all the meanings that I already talked about. We're going to provide SDKs for many, many different stacks, hardware stacks, operating system stacks, and various languages and tool chains. Let's talk about endpoints. First, an IoT Hub is our unit of tenant separation. So effectively, when you create your solution, you get your own hub, and your own hub can scale up to millions of devices. You might have solutions that require multiple hubs, mostly if you want to have them in multiple regions for different environments. That really depends on your solution, but in general, you get your own hub. On the device side, we have 2 endpoints for every device. And of course, one device uses these endpoints to send and receive messages, and they're of course multiplexed on the same connection. If those devices are connecting through a gateway, then of course the gateway is accessing those endpoints for all the devices that they're connecting on behalf of. And of course, all those endpoints and those communications can be multiplexed on the same connection. On the back-end side, there is a device-to-cloud receive endpoint. This is accessed, of course, by your event processing component in your backend, and also by your runtime logic. Your runtime logic also accesses your cloud-to-device send endpoint that is used to send messages to the devices, and your feedback and monitoring. Then there is your device provisioning and management component that is accessing the identity management part of IoT Hub, thus effectively giving you the power to enable and disable setting credentials for each specific devices. Finally, there's your management of IoT Hub that allows you to set parameters for security, performance, and functional characteristics of your hub. We saw in the previous picture that the IoT Hub has effectively one phase for the devices and another phase for your back-end services. That is reflected in the SDKs that we provide. We're going to provide SDKs that are device-facing for devices and field gateways, and SDKs that are service-facing for backends and cloud gateways. The functionality will be different, but overlapping in some cases, but mostly we're going to target different platforms, and we're going to provide it in different shapes, so that basically they can be deployed on your depending on your solution. Of course, at the lower level on the wire, we will publish the protocol that the IoT Hub does expose. So you're not limited to those platforms, but of course, having access to the SDK, it's going to make things a lot simpler. In this presentation, we're going to talk about a sample scenario just to showcase what we have. And of course, this is pre-release code, so I'm going to apologize if things are not fully baked and if things kind of explode. But, you know, it's always good to see something instead of just imagining and seeing pretty slides. We're going to use a simulated wind turbine machine. This is a very simple simulator that is implemented as a console app. What it does is that it emits telemetry every second regarding parameters such as wind speed, torque, output power, those kind of things. And it's basically governed by a state machine. Starting, started, stopping, stopped. The idea is that the cloud is going to be able to control the turbine by sending commands to start it and to stop. The turbine is free to reject the command, to start the procedure, to stop the procedure independently, so on and so forth. The scenario starts by provisioning a device in the system. In here, there's a portal that provisions a device in a device registry that is implemented in a DocDB collection. This, of course, represents your own device registry and your own rest of the solution. It also notifies the device identity management of this turbine identity and of the security credentials. The simulator then, once the identity is in IoT Hub, can then connect using the correct credentials and starts emitting telemetry. Well, this telemetry is gathered from an event processor in the backend and is used to update the portal with the current values for all the simulators that are attached to the system. And then, of course, from the portal, you can send commands to the simulator. The simulator receives the commands and then can send a response through the device-to-cloud channel. The event processor then updates a command store that actually tracks the life cycle of the commands. Okay, let's look at how this looks like. Okay, so what you guys see here is like a very crude portal. What it has here, it has some devices that have been provisioned already. You see that there are some application-specific properties, the plant, the model, the telemetry component software version, and other things. There is also a key. And you can do some actions on this specific turbine, and there is also a command history. You see how effectively we're keeping track of what are the commands that are being sent and what is the outcome, and of course what some of those are not available when effectively you're like trying to stop a turbine that's already stopping, or trying to start something that is stopping, these kind of things. You're basically free to track all of those things. We also have in here, this is our event processor. Right now nothing is connected. In here there are some previous telemetry messages that I was sending. Let us now create a turbine. I think I'm like 7. Let's create turbine 8. What this is doing now, it is? Okay, great. We're creating a new turbine in our device registry, and we're also notifying the IoT hub that that's a new turbine. We also generated a key. This is the key, and now effectively the simulator will be able to connect to the hub using this key. The simulator is just a console app in here. Okay. Let's do turbine 8. And let's copy our key. Now, hopefully this will work. Let's see if I paid my dues today. Okay. Okay. So what happened now is that we connected as turbine 8. We started generating telemetry, and we're also listening for commands. Now in here, in this other page of the portal, we basically see this turbine. Well, let me show this first. We see that our event processor is getting the telemetry from the IoT hub, and in here I'm receiving it in the portal. Now what I can do is that I can send a command to stop this turbine. What's going to happen here is that it's going to receive a command, hopefully. Well, not here. Well, here it was, command stop. Okay, now it is stopping. What happens here now, this turbine is stopping, and here I also put in my command store that I sent that command. The idea is that when the turbine stops, right now, it sends an outcome for that command, that it should appear now here with success. Now, of course, we can start it again. This thing is starting, and just to show that we actually can have more turbines, we basically see, well, we're not seeing them. Okay, now we're seeing them. We're seeing multiple turbines running at the same time. Now, during the rest of the talk, we're going to see how we actually did all of those things, how we made use of IoT Hub, and what are all the services that it provides to implement solutions that are similar in spirit to this one. The first thing that we did was device provisioning, and it's clear that what I did was a toy. The thing is that device provisioning is used in this talk as effectively the making devices known to your system. Your system is usually composed of many, many subsystems, and IoT Hub and IoT Suite is going to be just one of those. There are many systems involved. What we're showing here, we're showing IoT Hub for connectivity, we're showing device registry so that you can effectively store your own properties and things, but then there are going to be many other systems. There are going to be ERPs, there are going to be other parts of your operational systems. Now, not only that, the device identity is also a complex concept. You could have composite devices. Think about an airplane or a train might not be one device inside IoT Hub. You could have like multiple sub-devices that are connecting independently to your to the IoT Hub. Not only that, there could also be many other concerns in your app that might restrict that might effectively complicate the concept of identity. There could be some procedural or regulatory issues for which you actually have to maintain different identities for the actual same thing. You might not be you might not be able to use the same identifier. You might have to translate in various parts of your systems. In this talk, we will actually focus for identity only from the connectivity perspective. Not only that, the provisioning journey is actually not just something that involves Azure IoT Suite. It involves many other systems, like I said, and it's very much application dependent. This is like just a simple example. A device can be provisioned in your system at the manufacturing system with an ID and an initial security credential. The first time that it connects, it's actually bootstrapped into the actual region that is supposed to be operating. This is very, very common when you have devices that, when you have like global operations and you do not know where the device is going to actually start working. So there's like a bootstrap process that ends up happening. This could effectively require some changes in the security credentials, some changes in the configuration. Now it's connecting to a different endpoint. As a result of a customer interaction, it can actually be activated. So now it's allowed to do its job and to send telemetry. Before then, maybe the customer didn't pay, you didn't want to let him use it for whatever reason. As there are other business reasons for which the device can be deactivated and deprovisioned. This is probably one of the simplest things that we can imagine. Most likely your own solution is going to have like a provisioning workflow that is a lot more complicated than this. In general, what we're going to talk about in this presentation are only the things that are relevant for connectivity. So in the specifics is IoT Hub for access and communication, and the device registry for query and discovery based on your application properties. This application, this device registry is implemented in a doc2b in my sample, but you can actually use anything, and it could also be like a complex subsystems that you already have in your solution. It doesn't have to be a document database in Azure. The Azure IoT Suite will provide an extensible set of provisioning APIs that are going to help that will help you integrate IoT Hub with the device registry. I will explain why that is important. But in general, the device provisioning orchestration is very much a solution-dependent component. It should be driven by a reliable framework, but in general, it is not something that we are tackling at the moment. So the device identity in IoT Hub is stored in what we call the identity registry, and it contains the per-device security materials, and it contains a state which allows you to disable and enable a device. So at the device level, you're able to control who is allowed to connect and how. The important thing is that this identity registry is used to effectively store security materials and to effectively do this blocking and enable and disable. It doesn't allow generic queries. This is why the device registry is so important, because the IoT Hub will not contain application-specific metadata. If you want, when you have an IoT solution, you will want to query based on application-specific metadata. In our example, you might want to have all the turbines that are in a certain plant, or all the turbines that had a certain property. You might want to store in the device registry some form of aggregated state. What are all the turbines that had a certain average output power in the last month? Those kind of things are not things that are going to be stored inside IoT Hub. So IoT Hub is the identity registry is used is authoritative only in describing which device can connect and how. After you have that, though, you effectively have enabled authenticated communications. Not only you, of course, have to ensure the identity of the devices that you're sending messages to. That kind of seems obvious. But also, IoT Hub is going to label every incoming message with the provenance of which device sent it and how was that device authenticated when that message was sent. That allows your backend to make informed decision when to trust those messages or not. Finally, we are very aware that authentication and identity is a very custom concern for many solutions. We will offer the ability to store device identities in AAD, which of course opens all the federation abilities that AAD has, on-prem storage and so on and so forth, but also to effectively code gateway scenarios where you actually are using completely custom authentication schemes and still have the ability to maintain your identity functionalities that IoT Hub exposes in your solution. So the ability to have access control and disable and enable devices, even if IoT Hub is not the component that is performing the authentication. Okay, let's look at how the identity registry worked in the sample. Okay, so in here we're in a class called the device manager. You see that we have an IoT Hub connection string, and we also have some information for my DocDB that acts as my device registry. I want to focus first on these first two methods. One is get device entries. The other one is get device key. If you remember the portal, I can pull it out here. We see like a whole bunch of property and also the key. What is happening here is that all the properties are actually retrieved from the DocDB. The DocDB is your store with which you're doing your runtime operations. You're going to do your queries. You're going to do your things from your device registry. I use a DocDB. You can use any system you want. You want to use SQL. You want to use anything else. But effectively, it's not IoT Hub. From the IoT Hub, you basically do point queries. Here, you get a device key for a single device. You can also get a whole bunch of other things. You can get the connection state, you can get last activity time, and a whole bunch of other connectivity-related information. But those are point queries to specific devices. We do not want you to use the IoT Hub as your authoritative store of what are the devices in my system. That's not what IoT Hub does right now. That's not what the identity registry is. In the device provisioning section, we have here a provision device method. Besides your check if a turbine exists, that's kind of, I will not really explain what that is there. We have like two things. First, I create the entry in my DocDB, and then I insert it in my hub. In here, there is no transaction support. So what can happen is that I insert it in my database, and it's not in my IoT hub. That is not terribly bad. What can happen is that the device tries to connect, it fails. We're going to get a notification from the monitoring feedback. I can fix this problem. Besides, of course, I can have retry logic and all of those things. We also suggest to use reliable workflow and transactional techniques, like you might use the durable framework on top of Service Bus to make sure that those things actually happen. That's actually what we suggest. However, this does not create a problem as what we can call a device leak. A device leak is effectively a device that you have in the IoT hub, but you do not have in the device registry. When that happens, you have somebody that can connect to your solution, but you effectively cannot discover it because it's not in your device registry. So it's, in general, be very careful not to have that happen. You can, and we're going to provide ways to sync IoT Hub with your device registry, but that's not really something that we want any solution to be doing repeatedly. Same idea for provisioning, right? We remove from the IoT Hub first, so that what can happen is that maybe it's still in the device registry, and you still avoid a device leak. Actually, before we end the device provisioning, the thing that is really important is this interaction between IoT Hub and device registry. It is fundamental not to downplay that. We really suggest to use reliable orchestration framework. Any orchestration framework works. But we really want to make sure that things are not used, put in the IoT Hub and then forgotten. Let's now go on the device to cloud messages. These are, of course, handled through the device to cloud send endpoint on the device side and received on the receive endpoint. The interfaces that we're going to have are at the when we ship are AMQP and HTTPS on the device side and AMQP on the service side. And of course, we're going to have SDKs for both of those things. It is the receive end side is going to be completely compatible with event hubs. So if you guys are familiar with event hubs, you're going to have partition receivers, so really high scale client checkpointing, and you're going to have all the integrations that Event Hubs already has, Stream Analytics, Storm, and all the ones that are coming. In general, every solution that you have that is using Event Hubs is going to be able to be migrated to use IoT Hub really easily. IoT Hub, though, is going to add other services in addition to what Event Hubs gives you. Is not only going to be the SDKs, but effectively this fact that IoT Hub is aware of the device identities lets you do many other things that with Event Hubs on its own you can't. There are also some performance characteristics that are different. IoT Hub has a much higher scale gateway. Is basically going to be optimized for having millions of devices simultaneously connected and sending telemetry. It's going to, of course, provide per-device authentication. So anybody familiar with the current Event Hub solution, you will not have to create per-device expired token based on an authorization. But you will be able to use per-device authentication stored in the IoT Hub identity registry. And of course, there's going to be connection multiplexing, both for gateways that you might have in your pipeline, aggregating traffic, and also for the same device between messages that are going to the device and messages that are coming from the device. In the sample scenario, what we did was actually very simple. The simulator was simulating all the parameters, output power, torque, wind speed, and etc. And they're basically sending it was sending every second a telemetry message through the cloud to the device-to-cloud send endpoint. There was an event processor. There was like a standard application. You can run that in a worker role. You can run that in a web job. That was an instantiation of an event processor host. That is actually the event processor host as any other Event Hub's receiver. We were using, of course, you can use Stream Analytics or Storm. I did not go in that detail as we're just focusing on the use of the hub. There are like many other talks in this conference that will tell you like great ways to make use of that data once it's in that pipeline. The event processor then identifies the telemetry messages and publishes them on the portal. It's simple, real-time things to just drive the page. In that could be writing to storage. That could be doing everything that you want to do with your telemetry stream. And of course, the telemetry portal was showing the things on a web page with a simple real-time framework. Okay, let's look at how that happened. Okay, what we see here is the turbine simulator. We see here that there is an endpoint, there is a turbine ID and turbine key, and there are a whole bunch of physical state variables, not particularly interesting. In here, what I want to notice is this device client. This is your client for the device that's part of our C# SDK. We're going to see later a sample on how to use our C SDK. C# devices are probably a minority at the moment. And it can be created with, of course, the host name, the turbine ID, and key. And then, of course, the simulation has a simulation loop that basically does the simulation. It has a send telemetry loop task that every second grabs the state and sends it. And it has a receive loop that is basically listening for commands. Let's look at the send telemetry. That is what we care about right now. What we do is that we create a new telemetry message. We create a new instance of the message class, and in here we actually put any byte array body. In this case, we're using just a JSON payload, but you can use protobuffer, Avro, any binary serialization that you want. You can also add properties, and then you send the event. Is as simple as that. On the receive end, what happens is this. This is a console app that is using an event processor host, and it, of course, is using my IoT hub as if it were an event hub. It's exactly the same code. This is actually the event hub SDK. What it's going to do is that it instantiates an event processor host in my event processor. When the event arrives, this is my process event method. If the event does not contain a correlation ID property, which basically is my flag for being a response to a specific command, so if it's not a response to a specific command, I effectively treat it like a telemetry message. Now, of course, this is a toy event processor. You will probably have things like version control. You might send a version number of the actual telemetry message to make sure to use the correct deserialization and all of those things. But effectively, in here, you have a scalable partition receiver that you can scale in all the ways that you're familiar with in event hubs. So if you want to write your own code with an event processor host, you can put it in a worker role and expand it to multiple instances. If you want to use Stream Analytics, you can do that. If you want to use Storm, there's a great Storm, HD Insight Storm and Event Hubs integration that's already shipped. You can use that as well. Okay. Cloud to device messages are basically the opposite stuff. You send something to your cloud to device send endpoint from the backend, and the device gets it from the queue endpoint. Now, of course, here the big difference is that we effectively are keeping one queue for every device. So those messages are durable and they are reliable. The device has to explicitly acknowledge the consumption of a message, so you do not have to code ACKs and code reliability on top of this channel. You have a send-receive pattern, and then the device has to either abandon the message if it wants it to still be there the next time that it connects, or complete the message if it wants it to be deleted. This is very useful for devices that are resource constrained and maybe they have no storage. That basically means that if the device is not able to process that command or that notification at a certain time, that doesn't mean that it has to be rejected forever. That command might still want to, the device might still want to have that command there the next time that it starts, maybe after a reboot or maybe later in time. Every message will also have a per message time to live. So you will be able to send an expiration time for all of the messages that you send. And then you can ask for positive and negative acknowledgements for the receipt of the message. What happens is that effectively, once you send a message and you ask for the ACKs, what happens if the device expires, you're going to receive a message that tells you that if the message expired, you will receive a feedback message that tells you that message expired, and also you will receive a message if the device actually completed successfully that command. Why this is important? We found that effectively many solutions required a kind of command lifecycle. Every message that was sent to the device had to be tracked and logged, and all the resulting actions that happen after an outcome had to be correlated together. So what ends up happening is that in the sample, I actually created this command store that does that in a very simple way, but is a pattern that we are considering and that we're developing for. So not only you can have correlated responses, but also everything else that results from that response, maybe a retry, maybe the abandonment of a specific command, can actually be stored and can actually be tracked. Another pattern that is very common is broadcasting the same command to a very large set of devices. When you start having hundreds of thousands, but even just thousands of devices, you might send commands to a single one, but many times you're sending commands to a vast set of them. Things like firmware updates. Well, we do not suggest send the firmware updates to everybody at the same time, but you usually want to stagger it, and they like quite sizable sets. Or request for more data, or a change of configurations. Those usually happens to a large set of devices, and you want to keep track of exactly what happened to each one of those messages. For us, it would be very easy just to send 1,000 commands. You send us one, we send 1,000. The hard part is when you have 1,000 things coming back at you, and then you have to track them. So with this. With the feedback that we provide, we basically make that easier. You can basically be there with your checklist and your list of 1,000 devices, and just wait for the feedback that is coming back from IoT Hub. You do not have to keep timers or to have like a process that continually scrubs that list. You just basically set your expiration time. When that expiration time is done, you will have received feedback for all of the devices in your list, and you will know exactly what you want to do for each one of those commands. In the sample scenario, what we did was very easy. The portal wrote something in the command store and then sent something to IoT Hub. The device was listening to a command with the receive loop method that we saw earlier, and it accepts the stop and start command. These commands are long running. When the device starts, it basically dequeues the command and starts executing it. It could also reject the command on the spot, and then when the command is completed, a response is sent through the device to cloud pipeline. Our event processor distinguishes those messages and effectively updates the command store. In general, you might want to do something that's not just updating a store. A pattern that we see people use is effectively redirecting those messages through a standard queue or topic, and then it being managed by a worker role if that has to be a real-time or more transactional work has to be done for those kind of events. Stream Analytics and Storm will all support this kind of pattern. Okay, so what happened is that first, let's look at how we're receiving the message. This actually comes again from the device client. We're still connected, and we basically just receive. And we're receiving in a loop, and there is a timeout. You can have that timeout as high as you want. That basically is the timeout that tells you when the receive is going to return, even if it did not have a message. That is the continue if the receive command message is null. That's basically what it means. That means that I waited for 5 minutes and I got no commands. You can have that time spent to be an hour, 2 hours. That depends on your connection pattern. Since we're here, since we're talking about that, device simulators these device simulators are assumed to be always connected. That is a pattern that is sometimes valid, sometimes is not. Some devices just wake up once a day, once a week, do what they have to do, and then disconnect. That is a pattern that we support, of course. The nice thing about reliable messaging is that it allows you to do that very easily. You can send a command whenever you want. You do not have to wait for somebody to connect to give it its command. Basically, you can put things in a queue, and when the device shows up, it's going to receive it. Once this is done, basically we're receiving the command, we're converting the message body. This is a JSON command, and then this is going to change the current command that is going to change the state machine. In here, I also have this complete async. You see here that when I'm done with my message, I complete the message. Notice that here I will complete even if I cannot deserialize the command. That is because if I cannot do anything with it, I will just not do anything with it and do not keep it in the queue. If there are any other exceptions, of course I'm not dequeuing the message. How you send the message is actually really easy. Again, I have here a send command, and we do the same thing. We update the docdb with my current message, and then we send the message using this service client. The service client is another portion of the C# SDK, and it is created from a connection string, and you see again that the message can be any byte array, and you then send it. Once the device receives the message, it will send a response, and that is handled from my event processor depending on my correlation ID property. This kind of pattern will be available to you also from Stream Analytics, so you will not have to actually write any code in here. You can just have a stream analytics job that basically bucketizes your messages. That is actually going to be a very important pattern, bucketizing your messages depending on message version, device types. It is a response. It is a telemetry stream. I want to do analytics on it, or anything like that. We show the C# SDK. I show the C# SDK because when you're flashing code on the screen, is a little bit easier to follow. But we will ship C SDKs. For devices, we're going to ship C99 SDKs tested and compiled for a variety of platforms and stacks. In here, you see a receive loop. There's basically the same thing that I'm doing with the device client. This is called an IoT hub client. You create it based on your endpoint, your device ID, and your key. You set a notification callback, and then from your callback, you can do everything that we saw in the C# version. Same thing for sending an event. In here, there's a little bit of the main is at the bottom of the screen. The top is a confirmation callback that is used if you want to subvert the TCP connection for an intermittently connected device. We basically give you a callback that tells you when everything has been flushed and it has actually been acknowledged by the IoT hub, so that you can subvert the connection safely. We have been talking about direct connections between the simulator and the IoT hub. That is a very simple way to enable scenarios, but many solutions will require intermediate steps. Usually, to translate between protocols, you might not have a device that supports AMQP or HTTP, mostly because it is something that we do not support yet, or because there was already a decision made to support something else, or because you have a brownfield scenario where effectively you already have devices in the field that are already talking your own protocol. That can be standards like MQTT, your own variant of MQTT, your own variant of something else. And of course, there is custom authentication. We will support, and we will try to support a vast array of authentication schemes. However, you could still have your own identity registry somewhere. There could be some identity stores and identity subcomponents that have already been built that you might want to leverage. So, of course, that is another reason to implement your own custom authentication scheme. For clouded field gateways, IoT Hub does offer many specific properties. We know that gateways are a fundamental part of IoT solutions. That is not a side case. That is not just a way to work around a limitation. Sometimes there are real needs, and gateways do provide added capabilities to the solution. So we assume the gateways to be a first-class part of our architecture. In order to do so, we support many ways to make the life of the gateway programmer easier. First is, of course, connection multiplexing. Your gateway can connect on behalf of devices, which means that IoT Hub maintains the same level of fine-grained control over the end device identities and still allows you to aggregate them and to do protocol translation and to do custom authentication on all of them in a gateway. We will also provide an extensible MQTT cloud gateway to both as a reference on how to program gateways, but also as a way to enable MQTT for your devices. There are a couple of patterns that I want to talk about. The first one is transparent versus opaque. A transparent gateway is a gateway where effectively end devices maintain their own identities, and IoT Hub is aware of those devices. That is very useful because you still have fine-grained control. You have device identities that are attached to all the messages. You have ability to do access control at an end device ID level. And opaque gateways, and there are some good reasons sometimes to go that way, is a gateway that effectively connects to IoT Hub as itself, and the end devices are effectively handled at the application level. In that case, you of course forgo some of the capabilities, but it makes the number of devices in IoT Hub smaller, and it might be required if you have, depending on your provisioning workflow. Then there are, of course, pull versus push gateways. A pull gateway effectively is a gateway that mediates between the devices that are already using a service-assisted communication model. So they go there and they pull their notifications, they pull their commands. They're not servers effectively. In that case, gateway can be stateless and it can be very easily implemented. When a device tries to connect to a gateway, the gateway just turns around and connect to IoT Hub using that identity. Very easy. Sometimes, though, especially when you're mediating between personal area network the devices that are acting as small servers, then your gateway is effectively required to push a message to the device. In that case, your gateway becomes more complicated because your end devices effectively have to register to the field gateway so that he knows what it has to listen to, what are the devices that specific field gateway is responsible for. The last capability that I want to talk about is monitoring. This is we believe that this is critical in an IoT solution. In IoT solutions, devices are nearly always unreachable. This means that any problem on the connectivity is effectively show-stopping. Besides like sending a field engineer and to do something on the device, that's basically the end of your device life, and it's usually very costly. For these reasons, we're basically building into IoT Hub a very, very verbose feedback and monitoring feature that allows you to get information regarding device connection and disconnection events, device error reporting, and of course, these events are emitted on an Event Hub compatible endpoint. Why is that? These events are effectively things that you might want to run analytics on. When you start having thousands of devices, those errors and events might sometimes be normal, they might sometimes be noise. Not all of them will require human attention. But think about this scenario. You might want to identify devices that try to authenticate and fail, so authenticate with a wrong key or password for more than 10 times in the last 24 hours. That could be a trigger for you of somebody trying to hack your system, or maybe just there was an error doing a rolling of a key or a cert. In that case, you can plug this event stream into Stream Analytics, run your window query, and expose the results as events. That's basically very, very easy to have that information out of your stream, putting it in a worker, and if you want, you can just go to IoT Hub and disable that device while somebody takes care of it. This is really, really easy to implement, and it's something that we can provide because we have knowledge of who's trying to connect or not, and we basically pass this information back to the backend. So what do we talk about? We basically introduce the connectivity component of the Azure IoT suite that's called IoT Hub that enables service-assisted communication at cloud scale. We talked about device provisioning, the difference between identity registry and device registry, and the fact that it does encompass multiple subsystems. We talked about bidirectional communications, device to cloud and cloud to device, the various things that we support, the fact that we're compatible with Event Hub, reliability, time to live, feedback. We talked about gateways, very briefly. Unfortunately, there's not a lot of time to go in much more detail for that. And of course, we talked about cloud-facing monitoring. There have been and there will be other sessions regarding IoT. There was Sam George's session, Create the Internet of Your Things, on Monday. There was Kevin Miller's on Wednesday regarding the Microsoft architecture for the Internet of Things. And tomorrow there's the security fundamentals. These are not all the sessions regarding IoTs. There are many others that are really cool. Please look at them. And I think that we are ready for Q&A. We have like 10 minutes. If you guys want to ask questions, I will take questions. Yes. Sorry? Yeah, if you can use the microphone.
You said the code's in pre-release, is that correct? That you're showing up here?
Yeah, this has not been released yet. We're going to be in public preview this year.
This year? Okay.
This year,
Any
yes.
like specific month you can share?
I do not think that I'm allowed to say anything.
Okay.
I think I said too much already. Yes.
Do you have any support for device management, like updating the SDKs on the devices or updating the code that I implement on the devices?
Yeah, we will have support for device management. The timelines for that are not. I cannot disclose timeline for that though. For what I showed, device management is not part of IoT Hub. It will be something that's built over it, and it's going to include many services. It is, of course, like a very wide topic. We are very aware of the device management portion.
One more question.
Yeah.
You said that those identities, they are device identities. They are specific to IoT hubs, and there are no metadata that I can connect to my backend system about device identities. Then how can I identify a device when it fails?
Oh, I see. So you get to set the device ID, and that is completely up to you. And that is effectively your excuse my SQL jargon, that's your foreign key. So you basically get to choose whatever the device ID you want, and then you get to update, read, delete based on that device ID.
It is not generated, it is set by
It is not
me.
generated,
Okay.
It is completely set by you.
In regards to the device IDs in an IoT hub, you mentioned that you have no ability to actually like query the devices. So how are you planning on doing cleanup and management of?
Okay, so we are going to have a way to do query of the devices and to do bulk import and export of those. So you will be able to sync and to effectively query the devices. They will not be expressive queries. You will not be able to say, I want all the devices that connected last day or things like that. That is, those querying capabilities are used for effectively non-runtime operations. So you should have the bulk of your querying should happen on the device registry. And then if something happens, you can of course manage, you can export all the devices that we're aware that you might want to basically move the devices from IoT Hub A to IoT Hub B and do these kind of things. We're aware of those scenarios. For those things, yes, of course, you will be able to do it. But for all the other querying things, we will heavily throttle those functionalities to be available only for those scenarios. We will not support 1,000 queries a second on like all the devices or things like that. Yes.
Hi. You spoke about patterns in terms of from device to client and client to device. Are there any patterns for bulk uploading data, right? I mean, in terms of
Yes, so we do not have them here because this is like I said is a pre-release. But yes, we're definitely looking at bulk uploading data, and I would love to talk to you more if you have like specific scenarios. Are you talking about messages? Are you talking about files? Or are you talking about streams like a video stream?
Files. Yeah.
Files.
Yeah.
So let's talk a little bit about exactly what you mean and what is your scenario. We have a whole bunch, but it's always good to have feedback. Yes.
So you mentioned that there will be a C SDK for...
yes.
And so my question, well, I'm assuming that it will use sockets for network communication. Now, the question is, will the SDK include a wrapper for those sockets? Because I know it's really painful to work with sockets in C. So I don't know.
I see. So the C, I'm not super familiar with the architecture of the C SDK, but all the SDK is going to be open source, and it is going to wrap most of the socket management for you. Now, there could be situation where you want to open the hood and see what happens, and you will be able to do that. But as it's shipped, it will provide like an end-to-end experience that will manage everything for you. You will basically just do send and receive like you saw there. You will still have to manage threading and all the funny things that you have to do in C, but yeah.
So will there be a minimum set of SDK calls, if you will, that will be enforced? Because, for instance, if there's an SDK dependency, and if the end device is, for some reason, does not have an acknowledgement component built in, then you have a state of flux because the hub is basically waiting for a response. But so, do you enforce, as part of the SDK, that for any devices connecting to the hub, that it has to meet a certain set of minimum protocols or minimum?
The thing is that there is no real way for us to enforce it, right? Because that is your code, and you might decide to acknowledge and to complete the message depending on whatever logic is in your app. That effectively means that I cannot enforce it. I can tell you to do it and be like really strongly tell you that, hey, you have to do it. But if you don't, what is going to happen is that after some time the message is going to expire.
Okay, so it waits for a certain period, and if it doesn't find.
Yeah, in general, if you never complete the messages, what happens is that the next time that you connect, you're still going to see all the old messages. You're going to soon find out that that's not really working for you. When you're debugging your service, the worst thing that can happen is that there's a lot of throughput, and basically you fill the queue. I think that the queue size per device right now is 50 messages. I do not remember the exact number. I do not think we finalized it yet. Okay. But that's kind of the order of magnitude. So the worst thing that can happen is that you send high throughput messages, you don't delete them, you fill the queue, and then either the sender knows or the device knows. You're going to find out that something's wrong.
Got it.
Okay, thank you very much, guys.